Hello everybody, how are you doing? Personally, I'm doing good. Thank you very much for tuning into this lesson. I'm Teacher Purity Joel, teaching mathematics to GSS students and senior secondary school students. As you can see, today we are going to discuss some few questions in grade 7 mathematics. So it's a revision, and I'm going to discuss or revise together. If you are new here, as I've said, I'm Teacher Purity Joel. I teach mathematics to GSS students and also to senior secondary school students. And if you have not subscribed, kindly subscribe. Thank you. Let us start together. Using factor tree method, work out the square root of 8,464. So, the keyword in this question is factor tree method. Factor tree method, not any other method. And what are we looking at? Square root. So, a factor tree method is done in this manner. We have the number 8,464. So we are going to use the factor tree method, whereby we are going to use prime numbers in that factor tree method. It's prime factorization in another word. So the first prime number is 2. So we are going to divide 8,464 by 2, and we are supposed to get 4,232. So you write 4,232, and we proceed. Check whether 2 can divide the number, and it's divisible by 2. So dividing by 2 will have 2,116. Yeah. We proceed further and check whether 2 can divide the number again by 2. Yes, it will be divisible by 2 to have 1,058. Sorry. We proceed and check whether, because of the space, I'm going to proceed here. 1,058 by 2 will have 529. Check whether 529 is divisible by 2, and as you can see, the last digit is an odd number, 9, so it's not divisible by 2. It's neither divisible by 3, because dividing by 3, the next prime number, we are going to get a decimal. So this number is not divisible by 3, not divisible by the next prime number 5, the next prime number is 7, and to keep on checking on the prime numbers whether they can divide 529 up to find that it can only be divisible by 23, and dividing the number by 23, we have 23, and that is the end of the factor tree. And therefore from that stage we can find the square root. So let us write how many 2's we have. 1, 2, 3, 4. So you'll have 2 times 2 times 2 times 2, then times 23 times 23. We have 4 2's. So because we are looking at square roots, we are going to pair the numbers. So we'll have these 2, and these 2. Then from each pair we pick 1. So we'll have 2 times 2 times 23. And this is supposed to give us 92. And therefore we can say from the factor tree method, the square root, I can write it here although I'm done with the question, the square root of 8,464 is equal to 92 from what we have seen there. So when you are taught to use a certain method, you ensure that you use that specific method, not any other method. The next question, let us proceed to the next question. A square notebook has an area of 1/16 square centimeters. What is the measure of one side of the book? 2 marks. We are first supposed to analyze the question. A given area being equal to 1/16 square centimeters, and then let us convert these to improper fraction. Anytime you are dealing with mixed fractions in a question, you're first supposed to convert that mixed fraction to improper fraction for you to work well with the fraction, because working the fraction as a mixed fraction is very difficult. So converting these will have 16 times 3, which is 48, then plus 1. We multiply the denominator with the whole number, then we add the numerator. That's how we convert. So this will be 49, and then the denominator remains over 16. Therefore, we can draw the square. We can decide to draw a sketch of the square notebook, and then we let the side to be x, because that's what we are looking for. So we'll have area of a square is given by, let me try to divide my space. Area of a square is given by length times length, which is length square. And therefore we can say that the length, which is x square, is equal to the area, which is 49/16, and this is square centimeters. So for us to remain with x, we find the square root of both sides. That is how we remove the square. To remove a square of a any number, we find the square root. So square root, the square root cancels the square, and we remain with x. So x will be equal to, we're going to find the square root of the numerator and the square root of the denominator. Square root of 49 is 7. What can we multiply by itself to get 49, which is 7, over the square root of 16 is 4. We can multiply 4 by itself to get 16. Therefore, the side measures 7/4 centimeters, and this can be left as a mixed fraction. For it to look better, don't leave it at that stage of improper fraction. 7 divided by 4 is the same as x being equal to 3/4 centimeters, and therefore that is the size, the measure of one side of the book. Yes, look at that. Good. So let us move to the next question. If there is anything you have not understood, feel free to ask the comment section and I will answer. A lifeguard on duty saw a person drowning in their circular swimming pool. He rushed to save the person and swam a distance of 3.5 meters. If the person was drowning at the center of the pool, what is the distance around the pool? So in this case, we are going to analyze the question, try to understand what the question is really talking about. Remember, I said one of my previous videos. If you have not checked my previous videos, kindly just check. I have very interesting lessons. I was saying that I said that mathematics and English are twins. You cannot evade English in mathematics because you have to analyze the question step by step and you need to understand the language. So we are going to draw a pool which is circular as per the question. This is just a sketch, and then it has a center. We were told that he rushed to save the person and swam a distance of 3.5 meters. If the person was drowning at the center of the pool, so definitely the lifeguard was at this point, then swam up to the center, meaning that is 3.5 meters. Therefore, we also know that as per the question, what is the distance around the pool? This means that we are asked of circumference, because distance around the pool is the same as circumference. This circumference, because circumference is the distance around a circle. Circumference, circumnavigating or circulating, yeah, circumference. So we'll have the radius is already given as 3.5 meters, and we know that circumference is given by 2 pi r. These are formulas that you are supposed to know. One of these days I'm going to give a video showing where the formula comes from, but I can just explain. If we have a circle with a certain radius, and then we have this pi is gotten from an experiment, especially the experiment is given in a grade 8, is it grade 8 or 7 textbook, whereby you have a radius is given, and then you do it as an experiment. You draw a circle, and then with that radius and the circumference, you just literally measure the circumference using a string, and therefore you substitute the value of the circumference and the value of the radius, you are supposed to get 22/7, that is, or 3.142, the radius. That is where the constant radius came from, the constant pi came from, because a certain mathematician noticed that however much you change the radius, the circumference, we have a constant pi, which is 22/7. So that is literally where these formulas come from. This formula come from, but at this level, we are not deriving formulas. So I'm just trying to say that you note the formula. Circumference is 2 pi r. Most of some students, I don't know why they get confused of this formula, circumference and area. You find that sometimes a student or a learner is doing circumference but finds themselves writing the formula for area. Circumference is just that distance. You don't need to square the radius. Remember, in distance, we don't square anything, but in area we square, in volume we cube. So don't confuse the formula. Area is pi r square with circumference, which is 2 pi r. Yeah, so let us substitute our values in the formula. We'll have 2 times 22/7, which is a constant, times radius 3.5 meters. And this is giving us 22 meters. Yeah, the answer is just in meters because it is circumference, distance around the pool. Yeah, 22 meters. I've talked much in that question, but it's worthy, I know. Yeah, sometimes it's good to explain where some things come from and also taking note of differences between certain formulas or certain formula which confuse learners. So let us move to the next question. As you can see, during a school trip, grade 7 learners traveled for 3 hours to their destination. If the average speed was 80 kilometers per hour, how far was their destination from the school? So in this case, we are given time, and we are also given speed. So the speed is given as 80 kilometers per hour, and the time is given as 3 hours. So we know that we are supposed to know that speed is equals to distance over time, but in this case we are asked distance, how far, meaning that we are looking for distance, and distance is given by speed multiplied by time. So with the formula, we can substitute, we can replace the values given in the formula. So this will be the speed, which is 80 kilometers per hour, multiplied by time, which is 3 hours. And this is supposed to give us 80 times 3, which is 240 kilometers. As simple as that. I don't know why students go wrong with this simple mathematics. The key point here is analyzing the question. What are you given? What are you asked? Do you know the formula? Can you substitute? Can you multiply correctly? And you end up getting your 2 marks. As simple as that. So let us move to the next question. Allow me turn my paper. Yeah. So the diagram below represents Hekima Junior School. Work out the area of the school in hectares. Yeah, so this is the land represented here, this junior school. As you can see, the height wasn't given, but I had to find a height because there is no way you can work with a question. I think it was just an error, a simple one. So I look at the shape of the figure. What is the shape of the figure? Correct. This is a trapezium. And in this question, we are supposed to work out the area. Not the perimeter, not the volume of whatever, although we cannot get volume of a figure. So you need to get the keyword in the question. What are you really looking for? So, how do we get area of a trapezium? See that area of a trapezium is equal to a half A plus B times H. And then this A and B are the parallel sides. Which are the parallel sides here? This side and this side. Look at that. Get to know the formula. Are you able to identify the unknowns? Can you substitute the unknowns with the knowns? Okay. So let us substitute together. We'll have a half into, any of them can be A, any can be B, because we're just adding. Doesn't matter where you place your A and where you place your B. Yeah, so we'll have 500 plus 300 into, our height is 200 meters, so 200 meters. Now look at this. During marking or assessing my students and the learners I've come across, you find that they do some mistakes in this question. Somebody writes the formula very well, right? Substitutes very well, correct? But at this stage, they do a mistake. Which is the mistake? Taking a half, multiplying by 500 directly, then add 300. What is this student lacking, or what is the mistake this student doing? The mistake is not following BODMAS. First, do away with the brackets. Whatever is inside the bracket, add 500 to 300. Because when you multiply a half by 500 alone, what have you done to 300? And you can see that a half is outside and should be multiplied to the two, 500 and 300. So instead of multiplying or opening the brackets, you can as well open the brackets, but I prefer following BODMAS by first doing away with the brackets or working out what is inside the brackets. So this would be a half times 500 plus 300, which is 800, then times 200. And this is supposed to give us 80,000 square meters. Remember, we are looking for area. And before that, go back to the question and check whether there is any further instructions. After getting the area, we are told that the area should be in hectares. So now, the reason as to why the question is awarded 3 marks is because of that condition of how you are supposed to leave your answer. You are supposed to leave your answer not in square meters, but in hectares. Do you know the relationship between square meters and hectares? So, you are supposed to know that. Let us now convert to hectares. Convert to hectares. We are supposed to know that 1 hectare is equal to 10,000 square meters. And because we have 80,000 square meters, we can write 80,000 square meters will be equal to how many hectares? Another issue is here. Can you cross multiply this correctly? Some learners make a mistake here. So we multiply, we cross the arrow, we multiply by crossing. Then the one that does not have a partner, we are supposed to divide with that. So this one we multiply, then we divide by this one. Some students or some learners take this times this, then divide by this. It's very common. So we'll have 80,000 square meters multiplied by 1 hectare divided by 10,000 square meters. Square meters cancel square meters. 4 zeros cancel 4 zeros. This is 1 hectare. We remain with 8 times 1, which is 8 hectares. Yes, that is it about that question. And you get your 3 marks. Very simple. The next question is a commonly asked question. As you can see, I know you've came across the same. Arrange the following fractions in descending order. Descending is the keyword here. What is to descend? Yeah, when I was in school, sometimes back, my teacher used to tell me this, and I've never forgotten. And at that age, it helped me. He was relating this to CRE, or a biblical way whereby we learn about the going up of Jesus, whereby we are talking of Jesus ascended to heaven. He came from the earth and then he moved from the earth up to heaven. That is, I think you are getting me, ascending. So ascending is from down to up. Descending is, or Jesus will descend, will. He has already ascended, but he will descend. He will come from above to below. I think that my teacher tried to explain it in a good way, and I got it and it helped me. But now I know what is to descend, what is to ascend. So to descend means decreasing from largest to smallest. So you can note down somewhere largest to smallest. So you are supposed to arrange these fractions from the largest to smallest. You cannot compare fractions by just looking at them when they don't have a common denominator. So we are supposed to write these fractions to a common denominator. And how do we do that? Can we first know the LCM of these denominators? Yes, it's possible. LCM, the least common multiple, 16, 8, 4, and 2. Can do it together. We'll have by 2, this will be 4, not really 4, 8, 4, 2, and then 1. Further to 2, this will be 4, 2, 1, 1. To 2, this will be 2, 1, 1, 1. Then 2, it will be 1, 1, 1, 1. So LCM, we need to leave every column with 1, 1, 1 at the bottom. Yeah, that is it about the LCM. Now let us multiply the 2's. So these will be how many? 1, 2, 3, 4. This will be 2 times 2 times 2 times 2. Look at this again. I don't know. I usually note the mistakes that learners do, and I keep on talking about them so that if you are in that trap, you can get out of it, because it is possible. Some students or some learners, when we have numbers being multiplied, repeating themselves as you multiply, you can just say 2 times 2 times 2 times 2. How many 2's? 1, 2, 3, 4. And you can just say 2 times 4, because the 2's are 4. Not really. This is just the same as 2 power 4, not 2 times 4. Are you getting the difference? Yeah. Or else you can just say 2 times 2 is 4, times 2 is 8, times 2 is 16, because 2 power 4 is 16. Yeah, avoid that mistake. So, okay, this is the LCM. So now let us write the fractions with the denominator 16. 9 over 16 is already in that form. And then we have 7 over 8 will be the same as, what can we multiply by 8 to be 16? 2. So 7 will be multiplied by 2, which is 14 over 16. Yes. Again, we have another fraction. 3 over 4 will be the same as, what will we multiply by 4 to have 16? 4. 4 times 4. So this will be 3 times 4, which is 12 over 16. You can also multiply the fraction by 16 to see what you are getting again. Then you make the denominator to be 16. Yeah, we have very many ways of doing that. We also have 1 over 2 is the same as, what can we multiply by 2 to get 16? 8. So this will be 1 times 8 again is 8 over 16. So look at these fractions. We have 9 over 16, 14 over 16, 12 over 16, then 8 over 16. Now we can compare the numerators, the largest to the smallest. Between 9, 14, 12, and 8, which is the largest? Correct, 14. So the first fraction will be Not 14 over 16 now, but in this case the original fraction, which is 7 over 8. So 7 over 8, comma. The next one is correct. 12 over 16, which is 3 over 4. Then the next one, of course, 9 over 16. Then the last one, yes, 8 over 16, which is 1 over 2. So that is it about arranging the fractions in descending order. Yeah, you can see. We also have another method which we can use apart from multiplying or making the fractions to have a common denominator. Which method is that? Yeah, you are correct. We can change the fractions to percentages by multiplying each fraction with 100 and then convert. That will be converting the fraction to a percentage. Then you compare the percentages directly. Then that can also help you arrange the fractions in the order requested or required. So we have those two ways for doing that. Good. Let us move to the next question. It has been interfered with by the question above, but you can see a water tank is in the shape of a cuboid. It measures 3 meters by 4 meters by 6 meters. Part A of the question, calculate the capacity of the tank in cubic meters. Capacity, and in this case cubic meters. So if capacity is in cubic meters, we call that volume. So volume of a cuboid, because in this case this is a cuboid and we're given the measurements. So volume of, remember we also have other shapes or other solids with other formulas to get their volume. That is why I'm talking of specifically volume of a cuboid is given by length times width times height. And we're given the measurements. So we'll have 3 meters times 4 meters times 6 meters. And this is giving us 3 times 4 times 6, which is 72 cubic meters, because it is volume. And you can see the m's are 3, so we cube. That's it. Imagine you get your 2 marks. As simple as that. We move to part B of the question. Convert the volume of the container above in cubic centimeters. Do you know the relationship between cubic meters and cubic centimeters? You don't need to cram. You already know from the simplest that 1 meter is equivalent to 100 centimeters. Who doesn't know that? So now, let us cube this meter. That will be, or let us cube this. cubing 1, just 1 times 1 times 1, which is 1, and then we cube the meters, becomes cubic meter, will be equal to cubing 100, will be 100 times 100 times 100, will be 1, 2 zeros, again 2 zeros, again 2 zeros. That becomes 1, 2, 3, 1, 2, 3, 1 million. Let us cube the centimeters. Look at that. Very simple. So 1 cubic meter is equal to 1 million cubic centimeters. But we only have 72 cubic meters. So we are going to convert these 72 cubic meters to cubic centimeters. So place your 72 cubic meters here, will be equal to how many cubic centimeters. Be very keen on where you are placing your value, because they should be at the same side, the values the same units. Some learners just place anywhere. Yeah, so be very keen. So these sorry, to be multiplied to this, and then we divide by that, and this will be 72 cubic meters, multiplied by 1 million cubic centimeters divided by 1 cubic meter. Cubic meter cancels with the cubic meter, and you can clearly see that your answer should be in cubic centimeters, and this is 72 times 1 million will be 72 million cubic centimeters. Have we answered the question? Yes, we have converted the cubic meters to cubic centimeters. Very comfortable. So that is it about today's lesson. Allow me to end the lesson at that point. Thank you very much for watching the lesson up to the end. If you're still here, you really mean a lot, and you really deserve to get good scores, because you are listening to the best, or you are doing the best thing. Thank you very much for watching. Thank you very much for subscribing, because I know you have already subscribed, because I requested from the beginning of the video. Kindly subscribe so that the channel can grow and I can bring more content, more lessons here, and we can learn together. If you have any question, don't hesitate to comment down below at the comment section. I'm ready to answer. You have a substrand. You know, here in JSS we are talking of substrands. In senior secondary school we are talking of topics. So if you have a substrand that you want us to look at, you have a question that you want us to discuss here, feel free to drop it maybe at the community section or the comment section. I'll really help. So feel free to interact with me. As I said, I'm Teacher Purity Joel. I'm taking you through mathematics, and I'm really ready to help you. Till next time, keep on tuned for the next lesson. Bye bye.